Hi, everyone. This is Sharon Rice, the Makerspace librarian here at the Rawlings Library, and thank you for joining me for Maker Mania Science with Sharon today. This is our second live broadcast. I'm really hoping that today I have sound so that you guys can hear me and learn all about our science experiment. Our science experiment today is a DIY lava lamp that kind of builds on the principles that we talked about last week with our density gradient tower. I filmed this video in the Idea Factory Makerspace today so that you guys could see it and make sure I had a really good camera angle so you could see everything that was going on. So without further ado, I'm going to go ahead and pop in this YouTube video for you guys to see the project. And then I'll come back live to chat a little bit and show you that it is in fact still working. So let me go ahead and get that YouTube video started for all of you. And then if you guys have any other questions, we'll answer them at the end of the program. Hold on real quick and we'll get it going. And welcome to our second installment of Science with Sharon, Maker Mania, here on a Friday afternoon. I'm filming today in the library makerspace, and I'm really excited that you guys have joined me today. We're going to be making DIY lava lamps today. I've already started making the lamp here. I have this water bottle. It's about a 10-ounce water bottle, but you can use any size you'd like. I filled it up about 1/3 of the way with water, and then I've colored that water with soap coloring. This is mica soap coloring here in yellow. You can use any soap coloring that you'd like. What I like about the mica soap coloring is that it's kind of iridescent, so it makes a cool swirl. Then I filled it the rest of the way up, this bottle, with just some plain old boring cooking oil I have no intention of ever cooking with, but you can use baby oil too. Baby oil would be clear and you'd be able to see things a bit better. But I need to get rid of the gross cooking oil, so we're going to do that. And last but not least, we're going to have our catalyst here for our lava lamp, which is our Alka-Seltzer tablet. So as you can see, I've put this part of the lamp together already. And the reason that it's separating out into these layers is the same reason that our density gradient worked last week, which is that the layers on the bottom, which is the water and the mica food coloring, is A, denser than the oil, so it's going to sink to the bottom, and B, the two liquids are what are known as immiscible liquids, so that means that they don't mix. The reason that they don't mix is because of the surface tension of each substance. So the surface tension of water is going to be less than the surface tension of the oil, meaning that no matter how hard you shake it and how mixed it looks, eventually the oil will find itself glop together and pull out of the water. They were never actually mixed together. They did not make a different liquid. They just made what's known as an immersion. So we're going to use the fact that oil and water are immiscible liquids to make our DIY lava lamp. And how we're going to do that is with our catalyst here, which is basically sodium bicarbonate and a little citric acid. It's going to create gas that's going to bubble in the water and cause the water to move up and down through the oil. So let's go ahead and break this in half, shove it into our DIY lava lamp, and see what happens. Whoa, there it goes already. So can you see, I'm going to move this a little bit closer. Can you see the difference in the liquid now as it bubbles and churns within this immersion tower? The chemical reaction of our sodium bicarbonate and citric acid inside of the water is causing it to fizz. But because the water doesn't mix with the oil, the only way that the gas can get out is to travel inside the water to the top of the tank and clump out there. If your lava lamp decides to stop working, because right up here you can see the little tablet of citric acid, just put another one in there and you can still see the same reaction. So there it goes, bubbling away, making a really cool lava lamp effect. Obviously, this lava lamp is not a long-lived lava lamp. It's not going to continue to bubble and churn and do these really cool up and down motions inside of your bottle unless you continue to feed it Alka-Seltzer tablets. But you're able to cap your water bottle at this point and move it to wherever you'd like. And whenever you'd like to see that particular reaction, you can see it here, bubble, bubble, bubble. Let me move you a little bit closer. It really does look like a lava lamp, which is super cool. You just need to break off another piece of Alka-Seltzer and throw it in there. So I'm going to do that one more time for you guys so that we can see. Plus, I think that it's pretty cool. When you do uncap it, you're going to have a little hiss of that gas that's being released during the reaction. But that's completely normal. It's not going to affect your lava lamp in any way. So there we go. Really simple. So if you guys remember, the science behind the DIY lava lamp is threefold. One, that water is denser than oil, so that's why the water sinks to the bottom. Two, that oil and water are immiscible liquids, which means that they are not able to mix due to their surface tensions. And three, the catalyst of the reaction between the sodium bicarbonate and the citric acid in your Alka-Seltzer tablet causes the water to foam, but the gas can't escape the water until it reaches the top of the bottle, so it's pulling all of those bubbles of water up to the top. And then the water is denser than the liquid, so then or the oil, so it falls all the way back down to the bottom, and it keeps doing that up and down, and that's what creates that lava lamp effect. That is the experiment. Please go ahead and if you have any questions or comments, send me a little comment on this video or on the YouTube video, and I'll get back and answer you as quickly as I can. And stay tuned next week. Next week, we're actually going to be studying the science of air pressure with balloon experiments. Until then, see you and have a great week. Bye. Hi everyone, and welcome to our second. All right, everybody. I hope you really enjoyed that video of me making the DIY lava lamp for you. Today in the library makerspace. It should be pretty awesome to try to make this on your own at home. You don't need to use the little water bottle like I did. That's just what I happen to have lying around as a container. You can use a glass jar. You can use whatever you like. I've seen it done pretty cool in different types of glassware. As long as you just have the water, the food coloring, some form of oil, and the Alka-Seltzer tablets. And if you're wondering if you can still use the same experiment again later, I did actually bring my DIY lava lamp with me. Here he is in all of his amazing yellow oily glory. And we're going to check and see if that reaction still happens to work live. So here we go. I'm going to drop in that Alka-Seltzer tablet, and if you guys can take a peek, it totally still works. So even though the reaction and the lava lamp kind of don't last a whole long time, just until the Alka-Seltzer dissolves, you're more than able to put another Alka-Seltzer tablet in it tomorrow or the day after and amaze your friends and relatives with this amazingly awesome DIY lava lamp, and then you can talk to them about density and surface tension and immiscible liquids. Immiscible is a really cool big word. So I really am glad that you guys joined me. Next week, like I said in the video, we will be doing an experiment talking about air pressure with balloons. I can't wait for you guys to tune in and see me next week. Until then, stay safe, stay healthy, keep baking, and I will be back here next Friday at 4. Have a great day, everybody.